Welcome. So this question says an 18 Newton force is applied to a particle. The force acts in a positive x direction. The particle is initially at rest. What is the momentum of the particle at t equals 6 seconds? So here's my particle, and 18 newtons is the force applied to it. It's in the positive direction. And the particle is initially at rest, so I can say VI is equal to 0 meters per second. And I can say T is equal to 0 seconds. And then at some time later, and what time is it later? The time later is T equals 6 seconds. 6 seconds, and we still have our 18 Newton force applied to it. And we want to know not what our final velocity is, but what is our final momentum. So I need something that links these things. I've got a VI, I've got a change in time, I've got a force. And the expression that comes to mind is force is equal to dp by dt. That's what Newton said, which is averaged over time, is that it's my change in momentum over change in time, which equals my p final minus my p initial, my final momentum minus my initial momentum over my final time minus my initial time. And so I can turn around and say, well, okay, that's pointing in a positive direction, so plus 18 is equal to p final, which is what I want, minus p initial. P initial is about this diagram, and we see that it's going to be the mass, which I don't know, but whatever mass it is, it's multiplied by 0, and something multiplied by 0 is 0. So my initial momentum is 0 over my final time, which is 6 seconds, minus my initial time, which is 0. So rearranging this, I can say that P final is equal to plus 18 times 6, which gives me plus 6 8 so 48, put down the 8, carry 4, 6 1s are 6 and 4 makes 10. It's going to be plus 108, and it's going to be momentum, so it's going to be kilograms meters per second. So there's my answer. Just a word, from our problem-solving strategies point of view. Notice that mass was not given because it turns out that you don't need it. And if you're still working in phrases, so you don't really work in equations, but you try to work it out piecemeal, then what you find is that you can't work out your momentums because you don't know the mass, and that can be quite off-putting. It turns out I don't need the mass because the mass, whatever it is, times 0 is 0. So watch out for that. And if the worst comes to the worst, just assume a number for something that you don't know. And if you truly don't need it, then that number will just cancel away. So there we have it.